But to really get an understanding of how this all works, we really need to do some programming on this. So what I'm going to do is I'm going to implement a class version of the range function. So remember, the range function the range function is also an iterable object, and it basically goes from a start value to an end value by increments of 1. And that's all we're going to do for this range function. The actual Python range function also has a step, but I'm not going to worry about the details of that. Okay, so let's implement our first iterator. So what are the two things we need in an iterator? We need an iterable and we need an iterator. So I'm just going to name it a range iterable and range iterator. And so what's the iterable? Well, remember our iterable at the end of the day, so let's go back here. So iterable is the representation of the entire sequence, and we have to implement the iter method. Okay, so those are the two things we need to do. But obviously it's a class, so I also need a constructor. And what should be in something that represents the whole sequence? Well, I think a range sequence should have a start and an end. So let's do that. And so what we can do is we can pass in the start and end to our constructor, and it'll bind instance attributes to that. So self.start is that, and the self.end is equal to end. Whatever we passed in. Okay, then the only other thing I need to do for an iterable is I need to return I need to basically implement an iter method. So I'm going to do that. So what does the iter method have to do? Well, it says that I basically have to return an iterator. Well, my iterator is the range iterator, so I have to do something with that. But I haven't really done anything with the range iterators yet, so we'll come back to this in a second. So what I'm going to do here is I also need a constructor for this class. And since I need to basically still keep track of this, with an iterator, I need to the only difference is that I need to have a notion of the current position. So, but in order to have my initial starting position, I need to have a start, and I also know I need to figure out when it's basically ending. So I'm going to also have a reference to end. So in many ways, it's going to look similar to our iterable. So we're going to do this. And then there's one more thing we have to have in an iterator. Remember, an iterator must implement the next method, one thing, but it also returns the current element. So we need to have a notion of the current element. So I'm going to define a instance attribute of current self.current, and I'm going to so what's the current element initially? It's going to be the start. Okay, so now that we have this, what we can do is we now have an iterator. For the most part, we haven't finished the iterator definition, but the iter method can return this iterator. So we can return range iterator from the self.start to the self.end. So now we've basically finished the iterable class. Okay, because remember, the iterable class only needs to implement the iter method and, of course, the constructor, and it just has to return an iterator, and we have an iterator. So this is our abstraction for an iterator. But what does the iterator need? It also needs a next method. So that's important here. So we need to define a next method. Okay, so what's the next method supposed to do? It returns the current element. So remember, in this example, the next method had somewhere where it was pointing, it returned it, and then it moved on each time. So we need to basically implement that logic. So, well, one thing I'm going to do immediately is I know if it's the case that the current is equal to the end, because a range is exclusive, I know once it equals the end, I need to basically be done. So what I'm going to do is I'm going to raise the stop iteration error. Okay. So once I've done that, I can just do self.current. So how do we move to the next item in a range? We just increment this by 1. So that's what I'm going to do. Plus 1. And then, well, also I need to have some idea of what I'm going to return. And if I increment self.current, I can't just return self.current because then it's going to be off a little. So what I'm going to do is I'm going to initially bind result to self.current. So this is going to be what we're going to return. And then once I do that, I'm going to increment self.current, and then I'm going to return the result. Okay, so now we've implemented a range iterable and a range iterator. So remember, that's all we need for an iterator. We just need a next method. And for an iterable, all we need is an iter method. And of course the constructors. Okay, so now let's test this out. So I'm going to define numbers as an iterable first. So I'm going to define it as range iterable from 1 to 5. And now I'm going to get the iterator using my iter method. So iter. So now it's going to call this iter right here. So and it's going to return an iterator. And now what I can do is I can do next on my iterator and get, ooh, what happened? Where's this error? Sorry, I made an error. 113. Oh, it's gonna be self.end here. So actually, I'm actually kind of happy that this happened, because a lot of times we think that we can pass in these type of parameters to here, but we can't, because this is a method. So we always have to access this by its instance attribute. So I made that mistake. So let's try this again. So again, I'm going to define my numbers, define my iterator, and now if I have next iterator, I get 1. So remember, the first number is 1. If I do it again, oh crap. Let me try. Let's not make that mistake again. Okay, so I'm going to implement my next iterator, and I do my next iterator again, and then my next iterator again. So now I should do next iterator one more time. And now, since it's a range, it doesn't include 5. Remember, range is inclusive to exclusive. So it doesn't include 5. So after this, I should get a stop iteration. I do. Okay, so after this though, I kind of wanted to start over. Will it start over? No, it's done for. So basically this iterator is useless now. So that doesn't really help us. How can we get this to start over? Well, to get it to start over, I just need to repoint the current to the beginning. But where do I do that? Well, the moment it stops, I know I just have to reset it. So what I'm going to do, I'm going to set self.current to self.start. And after I do that, let's try this again. So I'm going to do my numbers again, my iterator, go through every next. And once I get here, I get stop iteration, and now it should start over. Bam. It's exactly what I want. Okay. And now, so remember, I define numbers as my iterable. So now, because numbers is an iterable, I can do a for loop. So for I in numbers, I'm going to print my I. See what happens. I get 1, 2, 3, 4. So because of this definition of the iterable class, this returns an iterable value, and then it basically creates an iterator, and then what we do is we go through each one by one next, and we get an output. So this is how a for loop works. All right. So let's analyze this function. So we have this. Sorry, not a function. It's a. Oh, also one more thing I forgot to talk about briefly. A little small thing. Notice that this constructor and this constructor seem kind of repetitive. So what you can also do is, you might be wondering, like, hey, why do I even need this range iterable function? Can I just use the iterator in general? And you would actually be right. So what we can do is we can make an iterator both an iterable and an iterator by just implementing the iter method in here. So what this is going to do though, because this already has a reference to the start and end. So the iterator also is an iterable because it represents the entire list as well. So we can just return self. So this is a little neat trick you can do with iterators that make the class definitions a little easier. But in terms of understanding what an iterable and iterator is, I think this is a good way to introduce it. But you can actually just do everything with a range iterator only. Sorry. Okay. Let's check this out. So what I'm going to do is I'm just going to redefine my numbers, and let's make it range iterator. So now I'm going to use my range iterator on from 1 to 10, let's say. And now I can iterate through my numbers and print them. And it'll work just fine. Because now this implements both, this is both an iterable and an iterator at the same time. So this is a pretty cool way to basically make the definition of an iterator much more compact. So in reality, you only need one class, and this one class needs to implement both the next and iter methods. Okay, so this is how the range iterator works. And one thing I do want to point out that I didn't mention, if I do next of numbers after I get stop iteration, it starts over, right? So I get 1. But notice what happens if I do a for loop after that. It only gets to 2, 3, and 4. It doesn't print out 1 because where's the iterator at? It's at 2. So when it returns the iterator, it's at 2 and it doesn't get the 1. So that's a key point here. So the only way to get the entire thing, you have to basically restart. So that's just a small caveat of how iterators work. But basically, so with the iterators, with today's discussion of exceptions and iterators, you can basically call yourself pretty good. You probably have a pretty good fundamental base of how Python works and coding in Python. So especially if you've been doing a lot of practice problems. So this is basically it for Python itself. Now in the next few videos I'm going to talk about, I'm going to introduce a topic that's very, very important in computer science called data structures. And we're going to implement some data structures and see what exactly a data structure is. And this is going to transition very smoothly into the next course that I'm going to be working on called data structures and algorithms. So that's some very exciting stuff ahead. But basically, this is the last video on some caveats of Python, and I'm excited to see you in the next video. So I'll see you later. Thanks.